Good morning, everyone. I'm Mitchel Snel. I'm a development engineer for ABN AMRO. And that means in my daily life, I'm working on test automation. And I do code changes in the test automation framework. I'm a junior developer. I've been coding Java for about a year. And yeah, when I started, I actually noticed something because, as you might have heard when you were listening carefully already, you heard some very fast speech coming through the speakers. That's actually coming through because I cannot see. See there, the title, Developing with Your Eyes Closed. Also, you see you don't see anything on the screen yet. That's not because I'm hiding anything, but it's more because I don't need the screen at all to write code. So that's what we're going to talk about today. I'm going to show you guys some things on how I look at code, how it's readable, and also to show some best practices on how you can make code readable, so it's actually readable for everyone. And of course, they're very helpful for me, but I think they're also just good practices to have when you write code on your own, because I feel that if you write code, it should be readable at least high level for everyone, not for only the people here in the room who have all these Java skills and know how variables work and if statements and for while loops. If your grandmother walks into the room and reads your comments, they should at least know what your code does. So that's what we're going to discuss today, but to at least start a bit fast. So don't worry, I don't expect you guys to pick this up immediately, but I'm just going to quickly show how I work. So we're going to go through something familiar, a Windows desktop. See if you guys recognize some items there.
Fill the view list, recycle bin not selected 1 of 17. Welcome to ABN AMRO 8 of 17. Microsoft Teams 15 of 17. Welcome to ABN AMRO 8 recycle bin 1 of 17.
So this is the normal working speed. It will come back in the end, but now to make it all a bit bearable for everyone, so let me get the screen visible.
Screen pattern disabled.
And there we go. We have our normal desktop. And now let me show the speech. Let me slow the speech down a bit.
Variant premium, voice serene dashing, volume 70, pitch 50, rate 85, rate 65, rate 55.
So this sounds already a lot better, right? I mean, it's not the most beautiful voice in the world yet, but you can hear it and you can understand it. So this is our desktop. Let's do this one more time.
Welcome to ABN AMRO 8 of 17. Recycle bin 1 of 17. Firefox 2 of 17.
So this is a normal Windows desktop, and this is also what I know. So you guys see the entire desktop, but you only heard a few items at this moment. So that is actually what I myself can hear there. Now let's do one quick other thing, and this will also come back later in the presentation.
Start window, Cortana window, search box edit blank.
So this is the search box of the Windows Start menu. Probably very familiar to everyone, especially if your computer is a big mess and you want to find something. It's very easy to do it via here. You don't need to browse through everything. So this is generally also how I can find programs, but you can see all the tiles here and the nice icons and all of that. Generally, I use this search field. And this way of finding things will come back later on in the presentation. Now, to get the actual code, so this is all normal Windows, right? And now we're going to an IDE.
Eclipse Dashboard, Eclipse SDK, Project Explorer tab control, tree view, Java demo collapse 2 of 6 level 0.
So this is our Project Explorer. It's a tree view, probably familiar to anyone who works with an IDE. This is Eclipse, but the same type of options are in all the IDEs, the big IDEs here. This is our demo project. You heard it already, it's Java demo. This is of course not code yet, so let's go down into that project and actually look at some code.
Expanded, 13 items. Level 1 src/main/java collapsed 1 of 13. Expanded, 1 items. Level 2 com.abnamro.cb.swift message utils collapsed 1 of 1.
Our package, we're getting closer.
Expanded, 2 items. Level 3 runs java demo.java collapsed 1 of 2.
And there we go, our Java file. Let's open this and see what we find inside.
Expanded, 1 items, runs java demo.java tab control, edit multi-line package com.abnamro.cb.swift message util semi.
Our package name. Of course, it does not mean anything yet. We have no idea what it does. Let's go to the class title.
Blank. Public class runs java demo left brace.
And as you can hear, this is the start. Our first brace as well. These braces will coming back because, of course, this is an open brace. It needs to close somewhere. And you guys can see now the entire class. But I just see this.
Temporary screen curtain, enabled until next restart. Blank, public class runs Java demo left brace.
So, then you have to figure out where that brace actually closes. And this will come back because this is one brace, pretty easy, beginning and end of your class. So you know where you have to look. But it's going to get more complicated because, of course, this doesn't do anything yet. We need a method. And especially in this one, we need a main method to run. So let's go down and figure that out.
Public static void main left paren, string left bracket args right paren, left brace.
So our main method signature. Probably all familiar in sounds, in what it is. Let's look at it.
Screen curtain disabled.
So here is our main method. And usually you, of course, know your braces and all of that. But this is how it sounds. And another brace, of course, to keep track of. Because we open our main method, but we also have to close it. And we have to close our class at the end. So let's go down into some code for this one.
String input file name equals quote qmessage.txt quote semi. String output file name equals quote response message.txt quote semi. Swift message analyzer equals new Swift message analyzer left paren, right paren, semi. Swift message analyzer dot message responder left paren, input file name, output file name right paren, semi.
So you heard a few things here. You heard Swift message analyzer. You heard it twice, yes. And we'll figure out why in a moment. You see inputs and outputs. And of course, this is also something to highlight because you need to give clear naming for what you're going to do. So an example here is we know it is an input. We have an output. It's a file. We have something called a Swift message, which is something known. And also, we see that back later, related to a library, so you can actually find more information as well. But even a Swift message, you can Google it and you can figure out what it is. Now, this project is very simple. It takes an input file name, it changes it, and it outputs a different file in a particular format. So that's what this one does. Now, let's go back up a moment, and there we actually see those differences because we heard Swift message analyzer twice. Here we go.
Swift message analyzer equals new Swift message analyzer left paren, right paren, semi.
So this is a normal initiation of Java, of course. Now, the difference is we can hear that now. So let's go to the beginning of this line, and we're going to go letter by letter, because this is how you figure out the details of your code. It's nice to read it in high level, but of course, now you can't write it yet. You don't know how to write it or how to expand on it, because you just hear it. You need more detail. So now we get that more detail.
S W I F T M E S S A G E A N A L I Z E R space S W I F T M E S S A G E A N A L Y Z E R space equals.
So we go until here, and afterwards we do the new one with the brackets and all that. You heard that in the line when we read it out completely. You heard some beeps in the middle. Those beeps are our capital letters. They're also at the beginning of this line.
S.
Like this. And why is that? Because we have something called a Swift Message Analyzer, which is a class. But we also have an object, Swift Message Analyzer, that we're going to use to run our methods later on in this code. So even though it sounds the same, it's something different. And here you go with the details of naming and also to figure out what is what. So let's go a bit further into this code. So now we are in our runner class, but we of course would like to see what it actually does. So we go further, so we go this line down again.
Swift message analyzer dot message responder left paren, input file name, output file name right paren, semi.
And now we of course would like to see where that message responder is, because it's not here. This is our runner class, and this is an implementation. So let's go there.
W-I-F.
So, well, let me start at the beginning.
S-W-I-F-T-M-E-S-S-A-G-E-A-N-A-L-Y-Z-E-R dot M-E-S-S-A-G-E-R-E-S-P-O-N-D-E-R left paren I-N-P-U-T-F-I-L-E comma outputfilename, right parent, semi.
And just to go through the entire line. So this is what you need to do if you want to figure out what your method is, what its parameters are. But now we would like to go to the method itself. So now we need to go back.
Write emaneliftupuo, comma emanelifupni, left ednoperegassem.
Here we are. Did you guys recognize input and output backwards? Because that's generally what you need to remember. So if you have like details, you of course remember them in the normal way, but you also need to recognize backwards and forwards because you need to go back and forwards through your code. Now let's go into this method, and now I'm also cheating like most of you because we have an IDE here, which of course gives us a lot of handholds. So we can go jumping straight into this method. We use hotkeys because a mouse I never use. It's all keyboard for me. So let's go into this method. We press F3.
Edit multi-line selected message responder.
Ah, there we are. This is all the information we currently have. Now if I maximize this, you guys can see the entire class already, or at least part of the code already. But if you only rely on the speech that you just heard, you only know the title of this method. So if you want to know more about it, let's go up a bit.
Star slash star at star at star at star at star this star slash star star.
Right, there you go, your famous Java doc. Probably never heard it like this one though. A lot of stars for this one. This is Java doc, and let's see if we can figure out what the method does.
Star. This method generates a Swift ACK message with the original outgoing message. Star attached. Star add param input file name. Star add param output file name. Star add author C65072. Star slash.
Yeah, that's because I don't want to put my own name in it. So this is my ID from work. But this is how you can figure out what the code does. So we know what it is. It creates something called an ACK message. And it has an input, it has an output file name. That's your parameter. You know who to write. So if the code breaks, you need to find me. And then you can go back to your signature. So let's go to the signature of this method.
Public void message responder left parent, string input file name, string output file name right parent, left brace.
And other braces to keep track of. And this is nice because this is the middle of your code. So this is just one brace, but it's definitely not going to be the last brace. So you have to imagine that when you're looking at this, that you need to know, okay, so I opened it at this signature. So when I go down, I need to wait until I find another signature and then see if this method is closed. But that's not all, because again, this is one brace. But when we go into this method,
string tech try left text in try left brace,
we see a try catch, which means another brace, something else to keep track of. And we're not done yet.
Text in Swift message Swift block to string message logger dot blank switch left blank case quote empty if left parent text in message dot contains left parent big 1 right parent bar text in message dot contains left parent big 2 right parent bar text in message dot contains left parent big 3 right parent left brace.
That was the longest if statement ever, right? Correct. And actually it has a reason. Because what you also, of course, could do is create if statements and if statements, right? You can check one, then check the next one, then check the next one. But those are other 3 braces you need to keep track of. Now you only have 1, and we're already at 3. So imagine that if you put in those extra if loops, you get about 5 or 6 to keep track of, and that's just within this method. Because we also have our class still, which we haven't seen yet. Because we have no idea where we actually are. We jump to the method, but we have no information about the place it's actually in. So let's go and check that out. Let's go to the top of this class.
MT1.
Let me go. Does it work what it's supposed to? No, I'm gonna cheat here. Whee!
package.abnamro.cb.swift message util semi.
Here we go, back at our package, which is the top of our class. Let's see where we actually are.
Blank import java.io.file semi.
our imports, because of course we have an input and an output, so we need to import and output files.
Blank, public class Swift message analyzer left brace.
And here we have our trusty Swift analyzer back. So this is the same one, and you can hear that.
PUBLIC space CLASS space SWIFTMESSAGEANALIZER space left brace.
And another left brace. So here we go. And if you listened well, this is the same Swift message analyzer we looked at in our main class, because of course we instantiated this class and then went to that message responder method. So let's go back there. And now you would think, oh, no, he has to go down with all these arrows again and then figure out with speech where it is. But no, because we have our IDE again. So I can press Ctrl-O within Eclipse, and this is going to happen.
Dialog, press Ctrl+O to show inherited members. Edit blank.
So here we have a nice list.
Tree view. Level 0 Swift message analyzer expanded 2 of 2. Level 1 target environment : string 1 of 14. ACK message : string 2 of 14. NAC message : string 3 of 14. Level 1. Big 1 : string 4 of 14. Big 2 : big 3 : string 6 of logger 7 of 14. Swift message analyzer left parent, right parent, 8 of 14. Left create JMS connection. Message responder left parent, string right parent, void 10 of 14. Level 1.
And here we go. If you press Enter, we go back to our method again.
Eclipse SDK, Swift message and
Sorry.
public void message responder left parent, string input file name, string output file name right parent, left brace.
So there we are. And now let's go to something else, because this is code. But of course, you also need to figure out what it's going to show to whoever is running this. So we used a logger for this. So I would like to show two examples. One of a logger message where I say, okay, that works. And one where I would say, well, I missed some information there. So let's go down.
String text in message semi, try left brace. Text in message equals read input file left parent, input file name right parent, semi. Swift message string equals swift message dot parse left parent, text in message right parent, semi. Swift block 2 swift message block 2 equals message string dot get block 2 left parent, right parent, semi. String message type equals swift message block 2 dot get message type left parent, right parent, semi. Logger.info left parent, quote message type quote plus message type right parent, semi.
So here we have a logger line, which means that when you run this, you have this on your console and you actually see this, right? You'll see an info tag and then you will see this. So it will give you something, a message type that will give in text. And then this will give you the actual message type there. So you know what you're going to get, right? It gives you the name of what it is and it gives you the actual data. Now let's go down to a line where I would say I missed something. And maybe you guys can figure out what we missed there.
Blank, switch left blank, empty if left formula / logger.info left parent, quote NAC message generated quote right parent, semi.
So any idea what we might miss here? Exactly. So you actually hear the string ACK message generated, but you don't have your ACK message. So it's nice to have that, but you still don't know what it's going to show you. But now let's kind of absolve myself here.
/ for test.
So it's just for testing. So it's fine to have that line in there. But you need to read through it. And you need to find it. And it's not clear information. So it's very important to have like clear information. If you log something, at least be clear what it is and also show the content that it's actually generating, not just the string. Because that doesn't tell you anything. You can put anything in there. So create your content there as well. Now, we heard something about an ACK message, which is another method within this class. So let's go there.
Dialog, press Ctrl+O to show in tree view. Formula tag message, formula tag Swift message left parent, string right parent, void 11 of 14 level 1. Eclipse SDK, Swift message analyzer.java tab control, edit multi-line selected formula tag Swift message. Blank, formula tag Swift message and public void formula tag Swift message left parent, string text in message, string output file name right parent, left brace.
So here we have our ACK message generation, and we do this with a library. As I mentioned before, this uses something called Swift messages, and Swift messages, they have tags and fields, and they are structured in a particular way. And to do that structuring for us, of course, we could write lots of string logic and concatenate those and then get to the correct lengths, because those fields also have to have lengths and particular inputs. But it's far easier to use a library for that, because then somebody already did the heavy lifting for me there. So let's go down and go and see that library at work.
Try left brace. Blank, system.out.println left paren, text in message right paren, semi.
And first, though, what we see is my way of logging. This is very basic, right? It's a system output print line. It's something you do in your hello world, and you just write it and that's it. For me, however, it's a way to log, to check if my code is working correctly, to debug it. Because imagine that when you track variables, you do that across your screen, right? You see it jumping across classes and you see it moving. I don't see that, because how would you keep track of it with speech software? Because it keeps on changing and changing and changing. That's the entire thing about a variable, right? So that is difficult to do. So what I did was I used this system out print line and put whatever I want in it, and I keep navigating it down to my code. So what I can do, because it's here, I could run this code, run through my main method, know that my class with my Swift message analyzer is instantiated correctly, and then see if this egg message gets triggered for its condition, see if that works. Because if it does, this line will get displayed, and if it doesn't, I know I have some extra work to do. So that's the thing here. For me, at least, it's very important, and I try to do that. I'm not perfect, so I don't always do it correctly, but write modular code, so write small methods which actually do one particular thing, so that you can debug it like this too, because you can just move this line down, and once you are at the bottom of your method, you know it's working, you can try on something else, and you can check this off your list. So that's a quick detour in this case. So let's go down a bit. We spoke about libraries before, so let's go down and find one.
Swift message string equals swift message.parse left paren, text in message right paren, semi. MT103 message equals MT103.parse left paren, text in message right paren, semi. String MT103 date equals MT103 message.get field 32a left paren, right paren, .get date left paren, right paren, semi. String sender equals MT103 message.get sender left paren, right paren, semi. Blank, Swift block 3 field 108 equals message block 3.get field by number left paren, 108 right paren, semi.
So here we go, and now the long track starts again, because I would like to show you guys the get field by number method. So let's go there. Can somebody tell me where to stop?
IELD space F IELD 108 space equals space MESSAGEBLOCK 3.GET.
There you go. Exactly. And now we have this one. But we want to know more about it. We talked about Javadoc before. And the nice thing about a library, at least if it's a good one, it also provides Javadoc, right? So let's go and see what they put here.
Dialog, document, heading level 5 link graphic open declaration.
Welcome on web pages. Here we go in HTML. So let's go down.
Heading level 5 link field. Heading level 5 link com dot. Heading level 5 link PowerDev software dot. Heading level 5 link Swift dot. Heading level 5 link model dot. Heading level 5 link Swift tab list block dot get field by number left paren, int field number right paren.
Very complex library, right? Let's go down.
Blank. Search and retrieve the first field with the given number. For example, colon, for 59 will return any of 59, 59A, 59F, etc. List with 6 items parameters colon. Field number the field number to search. Returns colon, the first instance of the given field in the message or null if none is found. See also colon, link get tag by number left paren, int right paren.
There you go. And for me, this is a perfect example on how to write this, because you see this method, but it shows exactly what the method does, but also how you can use it. So how you can actually start playing around with it. Because it shows you, it gives a field by number, gives you an example on how to use it. So here they give an example of 59, but as you heard in the code before, we use 108. So you can use it far broader than just the example or where you can think. And that's where the fun starts, of course, because then you can start playing around. And then coding gets fun, right? When you can do things which you didn't think were possible before because you find a new way of using existing functions. So for me, this is a perfect way of using it, and also why I would highly advise to use libraries, at least, of course, if they're made well, because this is a nice example, but I can imagine there are lots of things out there where you look at it and like, I have no idea what the guy did, but I'm happy that it gives the correct output. So let's go back to our Eclipse IDE.
Eclipse SDK, Swift Message Analyzer.java tab control, edit multi-line field 108 equals message block 3 dot get field by number left paren, 108 right paren, semi.
Okay, so now you remember that I showed you the start menu at the beginning, right, with the search field. So to show that, we have this is a very small project, right? It's a demo project, but if you want to navigate a project and you want to find a particular file, right, it's not going to be fun if you have to navigate through all the packages and figure out how the structure is set up, even if you have some help, because you know, for example, it's a Maven project, so you have some standard structure. But still, it can get very big and very confusing. If you know the name of a file, it's of course very nice to just find it directly. So let's go and do that. I'm gonna display here the search box to find a resource.
Open resource dialog, enter resource name prefix, path prefix or pattern left paren, star or camel case right paren, colon, matching items colon, java demo /src /main /java /com /abnamro /cb /swift message utils. Enter resource name prefix, path prefix or pattern left paren, star or camel case right paren, colon, edit blank.
A lot of information, right? But the only thing you need to know from this one is whatever you put into the search field, it'll search through your project and find it. So we started with run Java demo. So let's find it. I just type run in here and go down.
Matching items colon, list, runs java demo.java java demo /src /main /java /com /abnamro /cb /swift message utils 1 of 1.
Now, of course, to just show it fully, I just read this out completely. But as soon as I hear run Java demo, right, yeah, that's what I need. Let's go.
Eclipse SDK, runs java demo.java tab control, edit multi-line Swift Message Analyzer.message responder left paren, input file name, output file name right paren, semi.
There we go. And now just to show as a last bit, this is like, I slowed it down, right? So just let me show you guys how I would read until this same line. So we end it here. Now let's go to the top of this class.
Swift message.
There we go.
App.
Let me put the screen on black.
Temporary screen curtain, enabled until next restart. Variant voice volume pitch rate 55, rate 75, rate 85.
There we go. And now we go down.
Blank, public class run Java demo left brace. Public static void main left paren, string left bracket answer right paren, left brace. String input file name equals quote qmessage.txt quote semi. String output file name equals quote response message.txt quote semi. Swift message analyzer equals new Swift message analyzer left paren, right paren, semi. Swift message analyzer.message responder left paren, input file name, output file name right paren, semi.
Goes a lot faster, right? And that's also why it's still possible for me to actually do my work, because if I have to do this, like, what was it, 25 minutes, 30 minutes to do this circle, I would never get my work done. So this is generally how fast I work. And then one last thing, because you guys see here all the the tabs and all of that, like to figure out where something is located, right? Which code belongs to which part of your program. Let me show you an example there, because I didn't see that yet, but that's not completely true.
Dialog, list, Swift message, run Java, Swift message analyzer.java 202. Eclipse SDK. Field 100, Swift blank, string, end, Swift system blank, try, up blank, right brace, right blank, up, try left blank.
Let me go do this.
Dialog prep, preview, formula tag, Swift message responder left parent, string. Eclipse SDK, string, try, text, Swift, string, logit dot blank, switch left blank, case empty, if left, formula if left parent, text in message dot contains left parent, big 1 right parent, bar text in message dot contains left parent, big 2 right parent, bar text in message dot contains left parent, big 3 right parent, left brace.
Recognized it? You've seen it before. Look, it's this one.
Screen pattern disabled.
So we've been here before. However, of course, you use tabs, right, to indent and see, like, okay, to visually see on the screen what belongs into this if loop. Now, you might think, yeah, but I didn't hear anything about it. And that's true. And that's because we have something called speech verbosity. That means how higher I put that setting, the more information I get. But also, the more information I have to go through. So let's turn that on the highest setting.
Symbol level all.
So you put it in all. Let me slow it down a bit.
Variant rate 85. Rate 60. Rate 55.
And let's do this again.
4 tab if left paren. Text in message dot contains left paren. Big 1 right paren. Bar text in message dot contains left paren. Big 2 right paren. Bar text in message dot contains left paren. Big 3 right paren. Left brace. 5 tab formula next swift message left paren. Text in message comma. Output file name right paren. Semi / commented.
That's really annoying, especially if you hear this every line. And this is not even the worst, because, of course, this code also has a color. Usually it's black. If it's an error, it's another color. I can also make that visible. But that means that every time I go through this line, it will tell me black letters on white background, and then start really figuring out what it is. And when that color changes, it will tell me that. But that's, of course, information I don't want, because I'm not interested in the color. I don't really care. If somebody really wants another color, change it by all means. So it's always like a choice between the information you need and the detail you need to write good code. So because, as you know, you get small letter, you get big letter, you get parents, you need to know if it's a parent or a brace that you open, you need to know commas. So it's always kind of a struggle to see where you go. So to conclude this one, like I showed you a lot of different things and a different way of looking at code. But in the end, code is all text. You know, we know IDEs, we know it's, we have all these fancy things, we have the color coding, but we all started in Notepad with our Hello World program and compile it, right, on the command line and then get it working again. So that basic thing is all what it boils down to. It's all text, and that's also why it's perfectly doable. That doesn't mean, however, that you shouldn't write good text or good code. You know, you should do your commenting, you shouldn't write too complex code. I mean, we all know the spaghetti code, right, that you're at line 500, and you're like, I have no idea what happened in the previous 499 lines, but I think I need to be here. And that's not what you want, right? You want to understand the logic of the one who wrote the code. So, you know, do everybody, also me a favor, and, you know, write your comments so that everybody knows what the code does. Write modular methods which do one particular clear thing, and if you go over a certain amount of lines, just stop and start looking at it and like, do I really have to put this all in one function? And don't use too many if statements, while loops, too many conditions, because you all need to keep track of it. For this, this is more how to read code. I will be in the stand later this afternoon for ABN AMRO, and then we can also write some code. And you can actually see, okay, but what if you have to actually write, for example, a Hello World program in Notepad? We're going to go back to basics, and you can see if you can manage it, just using speech. I know most of you will be looking at the huge screen that is projected on behind you, but, you know, try and just see if it works. And, you know, and I would like to open everybody up for questions. Actually, for me, I started very online. Actually, I just went because, like my laptop, I of course use all the time. I mean, I did my studies on this, I did my high school, everything. So, you know, reading text and reading it with speech is normal. But code itself, yeah, I had to learn it like everybody else. It's a language, right? So I needed to pick up the grammar and the logic. And yeah, then it's just text.
Makes sense. I noticed that the Swift message analyzer class is named analyzer with an I, and in Java demo the variable is named Swift message analyzer with a Y.
Yes.
Is that a typo or a deliberate difference?
To be honest, I can say it's deliberate. That sounds better, right? But it's just a typo in this case. But good to notice. But to be honest, did you notice it because you saw it or because you heard it?
First because I saw it.
Yeah, yeah. So that's the thing, right? And that's also something that's we can go into detail in that on the stand later. But I use another machine called a Braille display where I can actually feel the letters as well, and then I also see those differences. But it's something I notice in my work as well. That for me it sounds the same, but it's written differently. But well spotted. So what I mentioned is, for me, I use this system print outline, and not necessarily to figure out what's wrong, but actually to see if the code runs up until that point. Because the basic logic is, if it doesn't get displayed, the code is not working, right? Because it's not reaching that line. So by moving that line of code down, that print line down, through the code, I can figure out if it's working or not. And I can, of course, place it in strategic places where I know it takes certain decisions, or where I use certain variables, just to see if they work correctly. So it's not about the message on the console itself, it's just if the code reaches that particular point. So generally, if you do this,
console tab control, pane.
You see a console, and you can search through it. So what I tend to do is, I generally build in the logger at a later point in time, so that I don't get all the information first. And I can search through my console, right? So I know what type of message I put into my printout line, and that's also why I'm using it, because otherwise I would be depending on integration of loggers, or if the import was correctly, and the system printout line is always available. So that's why I used it, and because, as mentioned, I can use specific text to find it back. I can put in whatever I like in there, but it's unique. So I don't have to worry about anything else that's happening. And then, of course, I can also read the errors back. But as we all know, most errors don't always relate to the actual code you're running. It's also like the fall down, right, of your errors. You have one problem, and then because you have that one problem, you have other problems, and it cascades down until your code fails, right? So you want to see that line first, and you know at which line it failed, and then you can start looking up. And then you move your line back up until it works, and then you start narrowing it down.
Are there any helpful plugins in Eclipse or in IntelliJ for blind people to?
Yeah, yes and no. Yes, in Eclipse there's an add-on that I'm using with this screen reading software that you just heard. And actually what it will do is, when I save my code, it will give me one particular noise for warnings and one particular noise for errors. And I can jump through the errors with hotkeys in it. So I can jump back and forth between, and it makes the problem solving accessible. So when you press Ctrl+1, I can actually see the solutions it provides, for example. So that's what that plugin does. For IntelliJ, to be honest, it's not that accessible. I can't use it at the moment.
So I also have some experience with Python, and you use tabs in that case to indent, but I didn't really hear tabs being written out. That's a setting, I think.
Yeah, I showed it at the end, actually. I put it all on sum, and if you listened well, you heard something like 4 tabs, 5 tabs, 3 tabs. That's your indentation. So then you know how it works. And actually, if you're interested and you like Python, this whole thing is open source and written in Python. So you can exactly figure out how it did this.
When you start working on new code base, be that work or a new library,
Mm-hmm.
how do you know where to start? How do you examine the code to know, hey, here's where I have to change something?
So generally, as I said, I just started. So what generally happens to me is I'm working on existing code. But if I build a new function, what I tend to do is I build a side project. So I build a smaller project where I do one particular thing. This is, for example, an example of this of such a project, because here we work with an input and an output file name. It's very, very simple. The working version of this code actually uses queues, where we get a message on a particular queue. We have to read it, we have to analyze it, we have to transform it into an ACK or an ACK message, and we have to send it back into that queue. But with that integration, at the moment, I ask help for people who actually wrote the central framework itself, because that is complex for me to figure out where in the code do I need to add my function that it doesn't break the other framework and it still does what it's supposed to do. So I tend to build a part of it, and then together with somebody else who knows the central code, I integrate it.
Thank you.
Can you also write unit tests and run them and see if the unit tests work or not?
Yes, I can, but that is mainly to do with the framework that we already have available within the bank. So we have a test framework, and there we use Gherkin and feature files to actually write tests, and that's also part of my work. So I write new tests which we need to do, and if that means, for example, that we have a screen where we tend, for example, to input data, but this is, for example, a screen where we need to click on a button first and then input data, that type of changes I do. And therefore also provide new functionality where possible. So that's kind of what I do. So I'm really helped by the framework that we have, and because I know it's a Maven and because the framework is kind of the same, I know where I also need to look for particular implementation classes and all that stuff, and also know where the responsibility of my team ends. Because of course, lots of times I try to run a test and then it fails, for example, where we create an account for within the bank. But I work for a team which does the international payments. So if it fails on account, I don't have to worry about it. I need to point to that team and say, hey, I did this didn't work. What did you guys change? So for me, actually, it's the framework that makes this possible. I can write it from scratch, but it would take me far too much time.
Thank you.
I'm wondering, is there anything special when you do code reviews with peer colleagues?
Actually, no. As I said, code is text, so I generally like to tell me, hey, this line you do this might not be practical, and I can jump to that line. I can show you that a bit more in detail in the stand later, but there are certain things within Eclipse that help me navigating code and looking at specific things. The lucky thing, though, is for me that because the way we work, you generate a function and you can figure out how you would like to do it. And of course, I discuss a lot with other developers to see, hey, is this a logical direction that I'm going? But when we do review, we tend to just look at the screens, and we do, well, what everybody does these days. So we go to Teams, I share my screen, they can look at my code, and they can say, hey, I see that you did this in line 295. Can you explain why you did it this way? And that's how we can review. Bitbucket and such I also had a look at, but we as a team did not deep dive into that yet. So we haven't done the official peer review way via Bitbucket yet. So we do it all between colleagues at the moment.
Do you have any tips for us to be productive in our EDE?
So, well, there's a thing like, and I know that lots of people probably know, but don't really consciously do it. Like, programmers generally like hotkeys, right? You want to look at your screen, you don't want to worry about the mouse. So the thing is, within Eclipse, I know, there are, as I showed you, some things like to find resources fast, to do quick search replaces through your project, for example. So generally what I would advise is look at the hotkeys of the IDE that you're using and see if that makes your work faster. And also be aware that you can keybind them yourself. So if, for example, I want to go to a Project Explorer, there's not a hotkey for that in Eclipse, but the option is there. So I can map my own hotkey to that, so I can quickly jump to particular places in the IDE. Same with the console you just saw. You can go there directly. You don't have to worry about it, find the toolbar, tap across, because of course I can't see it, I can't click it. That I can show in more detail also this afternoon, like how you can do something like a toolbar and like those visual details, because they are accessible. But you will also notice when you see that it takes a lot of time then to find a particular button. So yeah, just look at the hotkeys of your IDE, and when you write code and you want to figure out if this is working, everybody who's using a Windows computer, you can turn on narrator with Control Windows Enter, and it will read it out like we just did. And if you can still make sense of your code, you know you did a good job. Mm-hmm. Director is enough, to be honest. You have to imagine that if you have to write it down, how much lines of text you would need to actually describe that we just browsed through. So if you need to read it all, you still need to form that picture in your head. So it's easier to just browse through the folders. And as mentioned before, lots of project frameworks like Maven, for example, they have existing structures, right? So you can already figure out until a certain level how it's looking. So you can kind of figure out, okay, this is where my data is, this is where my code is. So that would help. And to be honest, and I know that's simply said, but to be honest, I would prefer that you just use clear Java doc for everything. So that if I go to a particular class, the runner class, for example, I know what the runner class does, what it's doing, and the deeper I go into the code, the more detailed I get. That's more helpful because then you can also only figure out the details you want to see. And you don't have to worry about the entire thing in between, because if somebody explains to me a Maven project once, I don't need to have it explained every time once again. So yeah, I would say you can be more flexible with comments, but of course, any
Secure
type of documentation
desktop window.
is helpful.
Windows secure
There we
desktop.
go. Sorry, computer locks.
Windows sign dash of Mitchel.
There you go.
Considering the time, I only have one question left. I don't know. Guy in the back was already.
Yeah?
We have a lot of contact with people. I know people who are also blind and do Java development, but we have to figure out everything yourself, like the tricks and
Yeah, for the moment I have to figure out everything myself, but I'm pretty sure I'm not the only one in the world. So if you ever find them or are at conferences where you think, hey, I saw this before, or see somebody walking around with a cane, you're like, hey, you know what might that person do?
Windows
Ask.
default lock screen secure desktop.
Yeah, this is also my life. It
Windows
always
sign-
talks back into my ear. That's generally why I use headphones at work. So yeah, but I would love to meet them. I would love to exchange ideas, to figure out shortcuts, also to advocate more towards accessibility in IDEs, because mostly it's a coding job. It can be fun, but it's also money, right? So at some point you run into that hurdle. So no, I haven't met them yet, but would love to do so. Thank you all. I think we're at the end. If you have more questions, I will be at the stand later today.
Windows default lock screen
I'm
secure
looking at you
desktop.
for the time exactly. When was it
Windows sign
again?
24:3.
Oh, okay. So, yeah, 14:40, I will be there. So from 14:40, you come to the stand, ask your questions. I'm happy to answer them, and I hope you all learned something new today. Thank you very much.